8-9 simple radical equations. When we're doing this, we're going to isolate the radical, then we're going to take the square root of both sides of the equation to remove the radical, and then you're going to isolate the variable. When you do this second step of taking the square root of both sides of your equation, you have to remember that when you take the square root of the number, that you have to put plus or minus in front of it. So, or if you take the square root of both sides, you take a plus or minus in front of it. However, with these, they're going to have the radical in it, so we're just squaring both sides. So if we look at example A, we have the square root of x is equal to 7. So to get rid of that square root of x and just get x, we're going to square both sides. Right now our radical is isolated, so we can just go into squaring. So the square root of x squared is just x, and then the 7 squared is 49. So x is 49 here. And then with any of these, you can plug it in and see if your answer is correct. So if you take the square root of 49, you get 7. For b, we have 3 times the square root of x is equal to 18. So we're going to isolate the radical first. So divide each side by 3. So we have the square root of x is equal to 6. We square both sides, so we raise each side to the power of 2. The reason why we do this is because the invisible index, or the index that's understood on that radical, is a 2. So in order to get rid of the radical, you would have to have the power of 2 that radical is raised to. So from here, we're going to have x is equal to 36. For C, we have 140 is equal to 2 times 9.8 times D. So if I do that 2 times 9.8, I'm going to get 19.6. So this is the same thing as saying 140 is equal to the square root of 19.6 D. From here, I'm going to square both sides. This 140 squared is 19,600. And that 19.6D is going to be on the other side because we get rid of that radical because it's raised to the second power. From here, we're going to divide each side by that 19.6. Oops. And then with this, you can actually move that decimal point over to the right one to make it 196 on the denominator. If you did that to the bottom, you do that to the top and add a 0 in. So 196 divided by 196 is 1, and then you have 3 zeros after that, so 100 is equal to D. Oh, I'm sorry, it's not 100, it's 1,000. You have 3 zeros, not 2. 1,000 is equal to D. There we go. For D, we have 15 is equal to 5 times 7x underneath the radical. So the 5 times 7x I'm going to do first. So this is going to be 15 is equal to the square root of 35x. I'm going to square both sides, get rid of that radical. So 15 squared is 225 is equal to 35x. Now I'm just going to divide each side by the 35. If you don't know how many times 35 goes into 225, you know that they're both divisible by 2. So divide both of them by 2. Or sorry, by 5, not by 2, by 5. Because they both end in a 5. So if we divide the 225 by 5, 5 goes into 22 4 times. With 2 left over, 5 goes into 25 5 times. So that's 45 over 7. And you can't simplify that any further, so it's just left like that. For our next example, we have this square root of 5x plus 1 plus 2 is equal to 6. So we're going to first isolate that radical, and we're going to subtract 2 from each side. So this is going to give us the square root of 5x plus 1 is equal to 4. We square both sides, and we have 5x plus 1 is equal to 16. We're going to subtract that 1 from each side to get 5x is equal to 15, and then we divide each side by 5. So x is equal to 3. For b, we have the square root of 2x plus 4 minus 7 is equal to 3. So we're going to add that 7 to both sides. We get the square root of 2x plus 4 is equal to 10. We square both sides. So 2x plus 4 is equal to 100. We're going to subtract the 4 from each side. We have 2x is equal to 96. And then we divide each side by 2. And get that x is equal to 48. For C, we have 3 times the square root of 5x minus 4 is equal to 8. So we're going to start by dividing each side by 3. So we're going to have the square root of 5x minus 4 is equal to 6. We square both sides now. So we have 5x minus 4 is equal to 36. I'm going to add that 4 to both sides. We have 5x is equal to 40. And then we divide each side by 5 to get that x is 8. For D, we have 5 times the square root of 6x minus 2 is equal to 20. So we're going to divide each side by 5. We have the square root of 6x minus 2 is equal to 4. We square both sides. We have 6x minus 2 is equal to 16. Add the 2 to both sides. So 6x is equal to 18. And then divide by 6 to get that x is 3. For example 3, we are dealing with these equations that have an x in them. So we're going to isolate the radical. So we're going to move the 2x over by adding it to both sides. And then we have the square root of 11x squared minus 63 is equal to 2x. From here, we're going to square both sides. So we're going to have 11x squared minus 63 is equal to 2x squared. 2x to the second power is 2x times 2x, so that's 4x squared. I'm going to get my variables together on the same side, so I am going to move the 11x squared, to both sides, and I'm going to get negative 63 is equal to negative 7x squared. I'm going to divide each side by negative 7. The 63 divided by 7 is 9, so I have x squared is equal to 9. Now remember, if we find this, we're going to take the square root of both sides to get x, not x squared. So x is equal to, remember, the square root of 9 is 3. However, we're solving for x, so it's plus or minus 3 for our answer. For B, we have the square root of 3x squared plus 9 is equal to 2x. Our radical is isolated already, so we're just going to square both sides. So we have 3x squared plus 9 is equal to 4x squared. We're going to subtract the 3x squared from each side, and we get 9 is equal to x squared. And then we're going to divide by 9. Take the square root of both sides here, and we get that x is equal to plus or minus 3.